All right, so we're talking about section 2.4, which is solving applied problems. So one of the things that we need to understand is that algebra is used to define mathematical relationships. So there's a couple different things we need to see when we're doing this, but a direct relationship is a mathematical relationship between two quantities, where one quantity is defined directly in terms of the other quantity. So remember, we're trying to translate English to algebra. And one of the first types of relationships is when a relationship is given directly. So variable expressions are used to define direct relationships. So let's go through a couple examples. It says, write variable expressions that define each quantity of the direct relationship given. So first of all, the direct relationship could be given as the motorcycle is traveling 25 miles per hour more than the car. So I understand what that is, but the first thing that we need to identify are the quantities involved. And again, the quantities is the speed of the motorcycle. That's one quantity. 25 miles more than the car means the other quantity is the speed of the car. So the two quantities are the speed of the motorcycle and the speed of the car. And these are the two things that we're going to translate. So if we think about how this is written, then we can use a variable definition. It says the speed of the motorcycle is traveling 25 miles per hour more than the car. So if the speed of the car, if we let the speed of the car equal x, so x is the speed of the car, then the speed of the motorcycle is 25 miles per hour more than. So now I can write the speed of the motorcycle as x plus 25. So these would be the variable definitions of that direct relationship. So let's try another one. The length is 4 feet less than twice the width. So again, the first thing that we're going to do is identify the quantities involved. So it's talking about the length is, and then 4 feet less than twice the width. So the length and width and the width. These are the two quantities that are being related to each other. So once we have the quantities, then how can we show the relationship? By defining algebraic expressions, right? In terms of that. So you notice it says the length is, and the length is given directly in terms of the width. So that means if I know the width, then I can figure out what the length is. So the width is actually x. So this is a direct relationship between the width and the length. If the width is x, then I just need to take 4 feet less than twice that. So now I can define the length as 4 feet less than twice x. So 4 feet less than, I'm going to be subtracting 4 from twice the width. In this case, it would be 2x. So again, I'm looking at how one quantity is directly related in terms of the other. The motorcycle is directly related to the car. So the speed of the car is x. And then I can just translate, or define 25 more than that. All right, so a lot of times it's kind of hard to realize what x should be. But if we read it, thinking of it as a direct relationship, we should be okay. So let's try another one. It says Monica walked a half an hour more than Matt walked. So what are the quantities that are involved? So I got Monica and Matt, but Monica walked, Monica walked a half an hour more than Matt walked. Well, the quantities that we're talking about, and that's what we're going to do, is list the quantities. And they're talking about the time that Monica walked. So one of the quantities would be Monica's walking time, and the other would be Matt's walking time. So this is the quantities, and now I want to be able to read the relationship so I can come up with the algebraic expressions that define that relationship. So again, it starts out Monica walked. So Monica is directly related to the time that Matt walked. So Monica walked a half an hour more than Matt walked. So in this case, if we let X equal the amount of time that Matt walked, then Monica's walking time, all we need to do is add a half an hour to that. So Monica walked, or Monica's walking time, is a half an hour more than the time that Matt walked. So we can always plug in values. So a lot of times we read the English and we can understand the relationship, like the speed of the car and the motorcycle. We can, when we read this, the motorcycle is traveling 25 miles per hour more than the car. We can answer questions like, well, who's going faster? Who's going slower? You know, the motorcycle, of course, is going faster. And just because we added 25 here, couldn't we have also defined, and I'm just going to make a note, if we just need expressions that give us the correct relationship, couldn't we have defined the motorcycle and the speed of the car, right? We could define or think of the car as going slower than the motorcycle. So if X was the motorcycle speed, then the car would be 25 miles per hour less than that, or X minus 25. And as long as I understand what the relationship is between the two, I can use different algebraic expressions as long as the relationship is correct. So a lot of times it's easier to just define it how it's written, but really we could define these as long as the relationship is there, is correct, then the expressions can be used. So again, algebra is an easy way to define these mathematical relationships between quantities. So to practice that a little further, then we want to be able to understand, first of all, when I see variable definitions, do I understand what the relationship is? So the first thing I want us to do when we actually see variable definitions like this, and they're defining expressions and what the quantities represent by those expressions, we want to be able to understand what they are and interpret what they are. So we can look at this and say, okay, if X is the gallons of gas in the first tank, whatever that is, 2X plus 6 is an expression that represents the gallons of gas in the second tank. So we can, just by looking at this, we know that the second tank has to have more gas in it, because I'm taking X and it looks like I'm multiplying by 2 and then adding 6. So of course it's going to be bigger. But how would this relationship that's given in algebra, how would that relationship, would be given as an English statement? Can you explain this relationship? that's given in algebra. So one of the key concepts we can do is just think about the definitions we have in algebra and then what they represent in English. So if I just take X, and that's the gallons of gas in the first tank, and just partially substitute, partially translate what this would say. So instead of saying 2x plus 6, basically represented as 2 times, well, X is the gallons of gas in the first tank, 2 times the gallons of gas in the first tank, right? That's X, plus 6, right? So 2 times the gallons of gas in the first tank plus 6 equals, that'd be is, the gallons of gas in the second tank, right? Now that's a straightforward translation just by substituting in English what X represents. Now, this is a way we could do that, but when we're translating to English, we want to be maybe a little more descriptive or use language that we would probably understand a little easier. So when you see expressions like this, I want to interpret what that means. So because the number of gallons in the second tank is defined in terms of the number of gallons in the first tank, instead, I'll probably start this out by saying the gallons of gas in the second tank is, and that's the equal sign. And then maybe we can represent this a little better. Instead of just saying 2 times the gallons of gas in the first tank plus 6, maybe we can say something like 6 more than, and instead of saying 2 times, we can maybe say twice the gallons of gas in the first tank. Okay, so that's just an example, like I said, of rewriting and understanding variable definitions. This is actually way more important, is interpreting algebraic expressions in terms of English. Okay, now, the next type of translation that we need to look at is a mathematical process. Is there some kind of mathematical process that involves the defined quantities? So we must be able to identify the variable expressions that define the quantities within the equation representing the mathematical process. So in part B, notice there's an equation here. It says, write an English sentence translating the meaning of the equation. Well, if there's no reference, I wouldn't have any idea what this equation represents. But because of my variable definitions, I actually do have reference. And so within this equation, I want to recognize the expressions that are defined. So the first thing I do is just pick out the expressions. And one of the expressions, the 2x plus 6, I can see that expression right here. And the 2x plus 6, remember what that means. That's the gallons of gas in the second tank, right? And I also have x, and x, I know this expression, x sitting here, is the gallons of gas in the first tank. So this equation does have meaning because it has these expressions in it. So the next part of this then is interpreting the symbolism in the mathematics around it. So the second step is to interpret the mathematical process, the symbolism, right? And what that's saying around it. So you notice we have a plus sign between them. And that seems obvious enough that it looks like I have to add the gallons of gas in both tanks. But then the rest of the equation says equals 45. So we can interpret that is that if we add or if we total the gallons of gas in both tanks, right? If we total the gallons of gas in both tanks, we can basically say that the total gallons of gas in both tanks is, which is equals, is 45 gallons. So once I recognize the expressions, and then I can interpret the symbolism around it. All right, so let's try this next one, number 9. I'll go a little bit quicker here. So the first part is just understanding how these things are related. And so I'm going to do some abbreviation, but X represents, and again, whatever the application is referring to, X is the length of miles of the first hiking trail, X plus 3 is the length of miles of the second, and 2X is the length of miles in the third. So the first part is, how are these quantities related to each other? Well, again, I want to look at, first of all, what X represents. And I notice that I see X right here. So now when I interpret that, so this first one, I'm going to look at the second, or the length of the second hiking trail is, that's equals, right? Well, it looks like I'm adding 3 to the length of the first hiking trail. So the length of the second trail is 3 miles more than the first, or the length of the first, right? So I got a relationship between the second hiking trail and the first because X is used to define the length of the second hiking trail. And I can also do that for the third hiking trail. And I notice that X is actually in here. So the length of the third hiking trail is, well, now I just need to interpret 2X. So, well, it's 2 times the length of the first hiking trail, or we could say it's double or twice as long as the first trail. So these are how these quantities are directly related to each other. And as long as I know what X is, I can interpret then how that is relating to the other quantities. So now let's look at the equation in B. And the first thing I want to do is just go through and recognize my expressions. So here are all the expressions. I'm trying to erase that. So here's all the expressions that are defined. So the first thing I want to do is recognize the variable definitions, right? The variable definitions of quantities or definition expressions. and I notice there's an x, there's a 2x, and then I see a 2 parentheses x plus 3. So I have an x, which is recognizable. I got a 2x, and then I got the x plus 3 in parentheses. Now, I know what those represent. Those represent the length of the first trail, the third trail is 2x, and the second trail. And now I just need to interpret what the rest of it is defining. So what is the rest of this in red telling me to do to these quantities? So this one, the left side, looks like I'm adding the length of the first and third hiking trail. So we could basically say that the length of the first and third trails, and then interpret equals, or that'd be is, right? And then how can we interpret this last expression? Well, it's taking 2 times x plus 3, which represents the second hiking trail. So we can say that is the same length as, or the same is the same length as twice the second trail. So I'm just going back and forth between what I recognize in the algebra and what's defined in these expressions. So as long as I can identify expressions that are defined, then I'm just left to interpreting. The algebra around it and telling me what to do with those quantities. All right, so again, direct relationships, how quantities are related to each other. How do I understand variable definitions for direct relationships? And then the other type of interpretation of, or translations in math, is equations or things involving, or mathematical process involving quantities that are defined. So as long as I can recognize the quantities in the equation, I'm just left to interpreting the symbolism in the math around it to understand what the equation is telling me to do with those quantities.